Welcome back to BCW, proudly brought to you by Haltech. This week, we are here on location at Haltech. We've got Scotty with us, and we're going to be playing 2Js. Can we make more power than a K24? Let's find out.
So what does everyone call you, Benjamin? Benny? Ben?
Benny,
Benjamin?
Ben.
B?
No, not so much. People that don't, typically the measurement, if someone actually knows me from like forever ago, like say school, I'm Ben. I was never Benny at school. But like anyone in car land knows me as Benny typically. Careful of the knee basher 3000. It's not too bad.
Benjamin.
It's only that you're 10 feet tall that's a problem.
No, fine. Love it.
I think it's go time, Scotty. We have already kind of got the Haltech base map in. I know the Injector dead times aren't probably spot on because we did kind of take a punt on that.
Do you know what the injectors are?
Yeah. I know what the injectors are, but I don't know.
There's no data available.
Yeah, well, I don't have any data, and Dave was like, "Oh, I'm not sure," so we'll just kind of chuck some numbers in.
Well, we might use some magic with that, and I'll show you how I find that, because I know that injector dead time is one of those things that's come up that everyone talks about. If the data's available for your injectors, fantastic. But what if the data's not available and you don't have the tooling to get that data?
And I guess the thing too is with so many injectors on an OE level being available, not everyone's always got the OE injector data. Like if you've pulled an engine out of a random thing to do a conversion, and then put a Haltech on it and all this stuff, we don't necessarily have that.
It's not realistic. So instead of being able to do that with like an injector test machine and then trying to find that dead time and the flow rate across every battery voltage and every injector pressure differential, we can do it with a really basic machine like a four-wheel drive dynamometer. So most people have got one of those at home, and you should be able to set that up reasonably easy. Oh, why are we here? It's for the food, isn't it? Yeah.
It's always the food.
For the lifestyle.
It's always the food.
Look, finding injector flow rate and injector dead time, I'll show you a bit of a trick how to do it when you can measure load on the dyno.
Yeah.
To make sure that you're kind of manipulating the right flow rate and the right dead time, because we're going to know roughly what the volumetric efficiency or the efficiency of this engine is. So that's going to be a certainty. Dead times, we kind of have a ballpark of what's going on, and flow rates, we kind of know what's going on. So we'll hold the thing at about 50 kilowatts and we'll manipulate all of those until everything comes together. And then we know we're in the ballpark, because the truth is beyond that, you're buying a known set of injectors, or you're finding someone who can flow all of that and actually provide the right data. I see so many that come back with data, but then you're manipulating it anyway because it's not right. Yeah,
so how many, like I guess the question is, how often do you see injector data that's A, is either accurate, or B, it's inaccurate?
If they come from a couple of brands that have got a really nice 3D table of injector flow rate versus injector pressure differential, and if you've got dead time versus battery voltage, probably going to be in the ballpark. I'm starting to see a trend of a lot of companies just copying data from popular brands and just distributing it, and we let it rip. You put that number in and look, it's a number, but you still need to manipulate everything to make it work. And it's not the end all. If you don't have it, a good tuner should be able to manipulate and make this work.
Yeah, okay. That's good to know.
I suppose getting back to this part of it, Davo set this up, which it makes me so happy, because the make or break for me is before we even turn the key on the thing, we need to go through every single setting, every function, configure all the engine protection, set everything up. And the beauty is, because Dave and I sat together for so long, is that we both do it exactly the same way.
Yeah.
So I've already looked through half of it and gone like,
close enough.
Yeah, this feels good.
Looks like I would have done it.
So we'll get to the bottom of that. I think we'll do this first. So the make or break here, I always say the hardest part is making that 100 kilowatts.
Do you reckon we'll make 100
kilowatts? To be honest,
kilowatts?
Today, the hardest part might actually be making... No.
There was some controversial comments in previous episodes where it's like, you spend all this time doing this and it's going to make less power than a K24. And you actually think that that comment's probably accurate.
Well, how do I tread around this lightly? I love you, Benny.
Be honest. You know what, though? This car has never, ever been about a power figure.
As soon as you open the bonnet, I like, obviously I've followed along, but then actually seeing it and seeing how this is exactly what I would expect. You know, when you go to a car meet in Japan, right, and you're in the middle of the night in the middle of nowhere, and there's a whole bunch of cars under an underpass somewhere, and they've all got their hoods open. this is what they look like.
Yeah.
All of them look like that. And I just think that's so cool. So I 100% get it. I love the look of the car. I like everything about it. A 2JZ GE VVTi non-turbo will make 110 kilowatts at the wheels, something
Yeah.
ballpark.
Stock form.
An EG or an EK Civic with a K24 A3 will make 138 to 145 kilowatts at the wheels.
So we're going to make 146 kilowatts somehow.
Got to make that somehow. I would rather tow a trailer with this because at $2,000, this is absolutely making more power than a K series.
Yeah.
So remember, it's this torque thing, right? Torque
Yeah, exactly.
and power
There's
and all this
also,
stuff.
yeah. A dyno number is one thing. How the car drives is another thing.
Spot on. So
They sound way better than
Facts. Facts.
stop it. Who's
got-
that guy?
That's Gian. Does he have a mic today? Oh, no one
Lucky.
even knows
Well,
what he said.
Hopefully no one heard him say
Yeah,
that.
yeah.
The sound. I hate, like, Kate, I am probably the biggest K-Series fan that there is.
Yeah.
And it's for good reason as well. I've got fairly solid backing to be like, yeah, well, it does work.
Yeah,
Like,
they're a good thing.
geez, they're a nice thing.
They
But-
just don't sound the greatest.
But I do like these. All right, so...
I have sent you a sound clip of this running already, and your first responses were, it sounds like a Big Cube L series.
Which, I stand by that, and I do love
I'm
an
fine
L.
with it.
I do love an
I
L series
took that
as well.
as a compliment because that was kind of what I was trying to embody in the concept of it. Like,
Remember all of them? How they all had, like, they had triple carbs and, like, it's pretty sick.
I can't believe, even with the ITBs, how much it still sounds like a carb. I thought there might have been some magic internally in the carby that made that noise, but it purely must just be that straight runner into the valve rather than going through a manifold. And
Remember when you had, like, triple carbs on this, how, like, you'd throttle pump and it'd get like...
yeah.
We can do that. We can just flood the
Jesus.
shit out of it down the bottom to get
Accelerator pump's too big.
that. And we'll get a bit of fuel spray and back out the front. Remember that? And then everything along the side, it'll
Be
get
all
that
greasy.
yellowy.
Yeah, greasy strut towers. And
We can give it a try and just see what the noise sound like, what it does.
the other thing I want to do test today is E85 actually worth it on an NA engine? Now I know
yeah.
I know you're just going to go, nah, waste of time, but we've never actually touched on it on the channel because we've never done an NA EFI car before to this level.
Nothing that's not like knock limited with what we're
Yeah.
talking about. Yeah, makes sense.
And this does have a little bit more comp than standard, which I still don't think 98 is actually going to have any knock issues. But I guess this is a really good conversation to go, when is the right or wrong time to go 98 versus 85?
And look, this is a part on this that we'll do this. We'll talk about, we'll do it on petrol, then we'll do it on 85, and we'll look at how much more torque it makes, and that's going to be that's where it's at.
Yeah.
So
Yeah, so it's like the Honda versus 2J argument. It's like the torque
yeah, and
increase versus not.
spot on, because up top it'll probably make the same power because it's going to run, being an aspirated style setup, it's going to run out of something else.
Yeah.
That's not going to be the limiting factor. So we'll do our oil pressure stuff. So rule of thumb here, I set them up so that we have, for example, at 2,000 RPM, 10 pounds of oil pressure.
when it
4,000
will go
RPM,
safety.
20 pounds. Yeah, so you can kind of see my magic there. That's kind of what it needs to stay alive.
Yeah, I'm actually surprised how low that is. I would have thought you'd want minimum of 25 at 2,000.
Remembering that we're not trying to measure like the wear of the oil pump. We're doing it's a failure mode.
Yeah,
or
true.
a huge surge mode.
If the oil filter's fallen off or something.
Yeah,
Yeah,
something
true.
like that. We've got delays and stuff here, so it has to go for 11 seconds. It has to be above 500 RPM for longer than 0.7 of a second. And if that happens, level 3, danger zone. Happy?
The highway to it.
Air temp, not too much of a consideration, really. Like,
The engine bay's got to be on fire if that's
it'll
a
have
threshold.
Yeah. Coolant temp, this will be an important one that we're going to turn on, and at 110 Celsius. Not the end of the world, just do something little.
Yeah.
Flex fuel, so right now we've got 14.5% in there.
I didn't have enough 98 to fill the tank when we're doing the fuel
no
level
drama.
gauge.
This is an interesting one, just so you know what this is. So flex fuel composition. So we're measuring the composition of the fuel through the sensor. Sometimes on, not so much on a car like this, but on a car that's got a big fuel system with heaps of fuel flow, or if you're running out of fuel and there's like bubbles coming through,
Like cavitating.
yeah, the composition sensor will actually detect that and it changes. So we stop measuring above 2 grand or above 1 pound. So in your case, above 2 grand.
Yeah, right. That's cool.
Quite interesting.
So it doesn't change the map mid power run or mid
No.
pass.
So basically, we know that if you're going, say, over 2,000 RPM, you're not refueling. So that sample was it. That's what we've got. We've got all of our, you've got your NOx sensors configured, and you've got 2 sensors on the side of the motor.
There's 2 on the side of the motor. I don't know if they're configured or not.
Okay, perfect. All right, we'll come back and we'll do that once we're up and running.
They are the factory Toyota ones. They're not aftermarket or anything.
Oh yeah, perfect. No, that's cool. All right, if we're above 75% throttle for more than 0.8 of a second, and it goes leaner than 14.0, we're like, yeah, we'll do something about that.
What are we doing with the brake pedal?
I just saw then it was on when it's off and off when it's on. So I've just
So
swapped
that's why the cruise control doesn't work.
Vehicle speed we're going to have a look at. So that's on the box, is it?
Yep.
Beautiful. We'll come back to that and calibrate that.
Can we just ignore the clutch pedal for cruise
Yeah.
to start with until we find it?
Yeah, no dramas. We're going to go for flex fuel from the beginning. We're going to turn on both of these things and then here we go. So these are the parts that I like to do to just make things easier for the tuner or whoever ends up looking at this thing down the track. They're going to look at it and go, wow, someone put in effort here. That's like impressive. So things like knocking out all the table axes because
We're never going to be in those.
we're never going to be in those boosted areas. I did knock off the 10,000 RPM load sight.
Yeah, I don't think we're going to need that.
Sure.
Yeah.
What
would you spin a 2J2? This 2J2.
This is the one with the con rods in it, eh?
Yeah, I mean, I hope it's got rods in it. It's got NA rods, NA VVTi rods, so small rods. Is that better or worse in an NA application if you're trying to rev it?
It's a good question. I don't have the experience to know the right answer to that. I think that, to be honest, I think that it's not going to be a conversation because I think it's going to run out of torque and power
Before we get
before
to turning it too hard.
Before that's a thing anyway.
Copy.
Yeah. Fuel prime pulse. So this is the amount of fuel that we pump into this thing. As soon as we see engine RPM, we just hold the injectors open to wet everything down for X amount of time. When we're on ethanol, we need way more of that than we do on petrol.
Yeah. And is that like a number in relation to the ethanol where you say there's approximately 38% more ethanol? Is it 38% more there, or you've got to slam like 100% more in there?
Buckets more so as a difference. So this is equivalent volumetric efficiency. So we're putting the equivalent of if the engine was 2,000% efficient, that's we would be putting that much prime in for the ethanol compared to 400 when it's petrol. You could do this in injection times and all this other. The reason why we do it in like equivalent VE is because it scales with injector size.
Yeah, okay. So if we change the injector size later, this table's still relevant.
It just figures itself out.
That's mad. Do you think some people get caught in the wormhole of like, they also get stuck in their way in tuning rather than go, oh, this is actually a much more modular type system. You go, cool, I can do it in that VE model versus like all these injection times and stuff you're talking about before, or it's just different strokes?
Man, it's 2025. Like, injection time tuning's dead. Like, it's over. Anyone who's tuning in injection time has got an older ECU that simply just doesn't do it.
Or they've been tuning for 100 years and don't.
The truth
or is it not even that?
Even if you... I remember when we moved from, like, E11 into Sport Series and went from injection to VE, I had a sound understanding of injection timing tuning. And had at that time probably been tuning for 10 years before that.
Yeah.
And we moved into VE tuning and I went, like immediately you're like, oh yeah, this just makes so much more sense and it's just nicer and you just get a better result.
Yeah, okay.
Like, yeah, it's just getting up, staying with the times. You know, I'm sure there's people that love carbies still, and like I'm not knocking on carbies. I like them too, but there's a time when you've got to just admit defeat and say, yeah, this is just better. This just works better. One of the other things I'm going to do here, file, restore defaults. Within the Haltech sort of ecosystem, I've got control over a lot of the default values.
Yeah.
So what we can do is, however this map was configured back then,
Like when
I
Dave
kn-
did it, you mean?
yeah, I know that all the defaults for the O2 control are really nice. I don't want to mess up the whole map. So all I'll do is just restore the defaults of the O2 control so I know I'm working from a known base. Then we go from there so that I don't have to retype in all the table axes and all the everythings. So now I kind of know exactly where we're starting from. And it makes things much easier. If anyone's got any default maps that they want updated or changed or anything like that, you can always email in and we can change a lot of that stuff.
Yeah, sick.
I find that saves a huge amount of time because you know where you're starting from. And like, imagine now if no table axes were there, no default values were there, like you'd be on the bench for 8 hours.
You're manually programming
Just
those things.
insane.
The one thing that I love about the Nexus series is that you can actually do bench configurations without a harness. Like you're literally powering the ECU or the VCU off of your laptop.
Spot on. Yep.
That's
so
wicked.
Powers up over the USB now.
Yeah. Yeah, I think that's a really cool addition. Is that pretty common across other ECUs as well now?
I think most devices in this day and age, yes. Yeah, like most things have kind of gone that way. I assume that's just a hardware thing.
Yeah. Yeah, you're probably right. And there's been an advance in the hardware that where it'll operate from the power supply from the USB versus needing an automotive, like car-based 12-volt put into it to operate.
Yeah, and it just knows now. Yeah. All right, we're looking pretty good here, I think. Wonder if you're going to get a discount on this tune because there's just like less to do when it's aspirated.
No positive atmospherage.
Literally half a tune if you haven't got 15 pounds of boost in it.
A lot of tuners probably won't like you saying that out loud.
Look, a lot of it, the truth of that, there's so much, all of the configuration stuff is the same.
Yeah, well, this is the first 100 kilowatts, right? We say this all the time, and people probably don't necessarily understand what that means, but I guess the crux of that conversation is the time in the tuning, or a lot of the time in the tuning is actually the pre-engine start configuration, like all of what you're doing now, all of the safeties and your RPM limiting and ignition correction and all sorts of stuff like that. Like that is where the time and this, I guess this is also the argument of tuners locking tunes. Like, are you paying for the service or are you paying for the IP? Because a tuner any decent tuner worth their weight is going to have all of their own sort of configurations and some of their own thoughts and processes. So I guess there's for and against for password locking ECUs and whatnot. And the other thing is too, I guess from a warranty perspective, not that there's really much warranty in the performance game, but the tuner has the confidence of releasing a car into the wild and it not hanging a rod on day one.
Yeah, makes it difficult, right?
Yeah, the owner pulls out and goes Larry laptop and puts another 10 pound or 10 degrees or both. And then all of a sudden you've got a 5-cylinder 2J.
These are the things that, I don't really get into the password stuff much. I think it's really nice to know if someone's been tinkering. But beyond that,
I guess most tuners these days probably also save their maps. And most people who are tinkering in the heat of the moment probably aren't smart enough to then put the original map back in it anyway. So every chance it's hung a rod or something, and then you go and pull the file out of it and compare it to the tune file you put in and go, oh, look there's more timing, less fuel, more boosts, all of the above.
It's probably realistic, yeah.
Like even the tinkerers aren't switched on enough to go, I saved the file before I started mucking around with it. They may have the file, but not the presence of mind to slam that map back in and go, oh no, I swear bro, it's how you gave it to me.
Yeah, look, truthfully, we don't see a lot of that stuff anymore.
I guess as ECUs are getting more advanced too, people are probably less, you're either at the point where you're almost tuning it yourself or you're relying on a tuner. There's not really much middle ground. Is that fair to say?
Yeah, that's probably right. And you know, with the amount of schools that are around now doing the learnings, like the online courses, they're fantastic.
Yeah.
And there is a lot of really good information available now. $7,000, that seems a bit
Low?
overboost cut. Do we need that?
No, I don't think we're going to need that. What at 1 atmosphere, it goes, you hit the windscreen. Runs out of vacuum and you headbutt the windscreen. That'll be great.
Maybe we should put it on
Let's
at
not.
£2, just in case something ridiculous. I don't know what would happen, but
I think we could probably got bigger issues globally if they're 2 pound of atmospheric pressure.
you don't think this car will be the thing that I'm worried about at that point?
No, I don't think that'll be a concern.
That's
bad.
I'm also in the habit of setting up all of the current stuff for the outputs on any of the PDMs to the highest current available on the pin.
Okay.
And a bit counterintuitive. I know people and ah about that a little bit, but I'm not looking for the device wearing out. I'm looking for a failure mode in the ECU, a failure mode in the harness, a dead short to go over that fuse current. So if my water pump's pulling 15 amps, I'm not setting the fuse current to 18. I don't go to Repco and buy 50 different mechanical fuse sizes.
And work out where it actually fails at.
No, I'm not really protecting the device. I'm protecting the harness.
Does that also help with, say, like a starter motor solenoid, for instance? That might like pull a heap of current initially, but then it drops away as it's cranking. Is that also a reason?
So that's the inrush that we're talking about there. Yeah, so we can do what we call soft start to do stuff like that. So we can, to protect the electronics and the harness, we can pulse that output so that it only gets, let's just say it's going to do 50 amps and then come back to say 20 once the inrush is there. We can pulse that output so it'll only supply 20 amps. It'll essentially feed that inrush current.
Yeah.
It'll get the motor up and running. Then it will just supply 20 amps and hold it.
Yeah, right.
So that's soft start. Thermofans, that's a really nice
Fuel
thing.
pumps.
Yep. Well, thermofans is a good example because if you've got a 20 amp fan off a AU Falcon or something, you know when they clunk on and the headlights dim?
The whole car pulls down, right?
So we can just pulse them in and just bring the fans on slowly.
Yeah.
It's better for the idle control.
So what do you do that at like a 50%?
Let it figure it out. So we just say, I'm gonna give you 5 amps for 5 seconds, then I'll give you 25 amps.
That's clever.
Mechanical tacho, you're not relying on that for anything, I don't think. No. I also like to do that as well and just turn off as much stuff as we can turn off because
it's not processing data that's not needed.
Probably, yeah, and we've got heaps of time for that, so I'm not too fussed about that stuff. It's more if someone else looks at it and they're too scared to turn that tacho output off because it's controlling a fuel pump thing in this car that I know nothing.
Third-party fuel pump controller or something.
I don't know. Yep, spot on. Then we'll go data logging. I like to set up the data logging anything above 2000 RPM. And then there's this thing here, log recommended channels. So I don't need to turn off and on. See how it added a whole bunch of stuff? You can muck around till the end of the world adding whatever you want. All the times here aren't right either. So I'm going to go restore defaults. I could try and remember what values I like them all at. Or I'll just go data log, restore selected. That's just going to clean.
Yeah, I was going to ask that question because I know you said before you were restoring the defaults and I was wondering, does that like full like factory, obviously that's not a full wipe of the ECU.
You can do the whole lot or you can do any individual section. So if I just go, I'll do that again, just so we can see what's going on. So in here, I could go for, see how data log's grayed out? So that is the default map already.
Yeah, okay, that's
cool. But I might go into data logging and go, just the switch input. I want to put that back to default.
Yeah.
Or I could go into the fuel map and go, I just want to redo the O2 control. Or I want to go in and just do the, I don't know, RPM limiter table. And I'll click on that one thing and go restore selected, and that'll put that back to defaults.
That's cool.
Cancel out of that. Back to where we were. This one here, if I turn that off and on, it adds all the channels.
Repopulates it all.
So every time we add a new channel, I go through and look at the channel and have a think about, is it important data to have? Like, is it some random channel like HCO1 on time? It doesn't need to be in a data log.
No.
Whereas all of these channels would be useful in a data log. So I'm trying to help for people to be able to just go, yep, turn that on, and then that way,
If you're doing diagnostics and you're chasing a specific thing.
odds are the data would have caught whatever happened. Yes, and we're down at the very bottom. What do we do now?
Start it up.
Okay. Sorry, we've probably run out of bloody film and hard drive and all this
film.
stuff.
Or battery voltage.
We're too deep already. Oh, battery voltage, that's always a gimme. Ready?
Hey.
Well, it's always good when they run. So, I have to excuse my terrible tables for a second. I'll knock off some that look dreadful. So, let's see what's going on now. Idle control. Get a bit of a feel for what's happening.
I know when we were playing around, when Dave was configuring it, we pretty much can't get much lower than that. That's
Because
basically
we've got air, like there's
just because of throttles. So I think eventually I'll actually pull the throttles apart and put the Tomei sauce in it
Oh yeah, yeah.
and just give that a bit more sealing.
Well, at the moment, we need 12.5 or 11% for them to open
Oh,
to
interesting.
stay
So
there.
we can
I'm
pull
going to
some
go.
out of it.
Well, it's still cold, so I'm just going to try and fill in
so
the
once
defaults.
it expands, it'll potentially add
Yeah.
more.
I really struggle with this, especially when we're using different throttles from different cars and all of this stuff. What I'm finding is that the blade, the outer diameter, the shaft, the whatever DC motor drive, like if you're using the BMW one or whatever, they're all growing at different rates. And we've got 6 individual throttles that are, at the moment, they're operating at like 1% open of the 5%. So at the moment, we're actually we're flicking the throttle between 0.2 and 0.5% open in order to achieve an idle value. Find me a factory car that does that.
Yeah.
It doesn't exist.
None of them do, because arguably, or we know, this is over throttled. I mean,
They're
it's
all
obvious
over-
by
yeah.
that data that it is.
They're all over throttled, and so insult to injury, like that BMW M3, the one that we all use, that the throttle puller off,
They have an idle control motor.
got a BAC valve.
Yeah, you've told me that before.
Like, it's got a BAC valve because factory cannot get that thing to idle off the blades alone.
So actually basically shut the blades
Yeah,
and then just use the idle control to
Yeah.
run it.
yeah. So we've got it reasonably stable at the moment. I'm just watching it as it's warming up. So all I'm doing is just filling in the base table based on what the output is doing. And if I kind of smooth L for linearize, the idle goes up because it's got short-term learning, and then it's going to go down again once the learning figures itself out, and we'll be in the ballpark. Bro, you sure that is an L series? How do you put the covers on the top?
That's pretty good, eh?
Listen to it.
All the brackets. Scotty's in love.
It's pretty. You know what I am in love with is the dash.
Yeah, it's cool, hey?
It's beautiful, really nice. I didn't like that hanging just then, so the D-cell offset start, we'll get rid of that. L series don't idle like that though. You know what? Some of them
Probably an
did.
EFI one would.
Bro, I love it. That is so cool. All right, so it was worth putting the time and effort into that to kind of get everything in the ballpark.
Yeah.
Do we put a cam in it?
Yeah, please. Put more in it.
We get
No.
to a point where when you've got nice catalytic converters and nice mufflers and
true.
stuff,
It just doesn't, it's
It
just
just doesn't-
diminishing return.
it just doesn't do it. Nothing happens.
Well, it already has reasonable cams in it and it was tame.
Oh, it's extraordinary. One of the things on this that I've got a little bit of magic, I've actually got, so the map prediction table, so that's basically asking when we blip the throttle at any particular point, what manifold pressure is the engine going to go to? It flips to a different table to do the fueling. Then when the throttles flatten out or settle down, we go back to the base fuel table.
So it's almost like an accelerator pump.
A predicted manifold pressure model.
Yeah.
We
But the
also
concept, if you go to Carbuland, is that's like accelerator pump giving you an initial hit.
spot on, and that's what this one is, the transient throttle enrichment. I've got a bit of a trick where on cars that have got multi-throttles that need a huge amount of throttle pump, I turn them both on,
Ah.
and I manipulate both so that
It kind of dances between the two.
and it works really nice. Like, look, I've got a mixture here. So for not even having the thing tuned yet, and we just sit like, to be able to blip it like that, and the mixtures go somewhere between 12.0 and 14.0 on a hard hit like that is quite impressive.
Spot on.
And we haven't actually done any work yet. So that makes me reasonably happy. I can pull some fuel out of the, so that's basically putting a smaller throttle pump jet in the carb. So that's that, and now we're going to
It's going leaner.
leaner, undo this.
So it didn't seem to love that.
Oh,
Way more responsive. Oh. Needs more pump jet, boys. You got your jet drill handy?
I think there is actually a set in that
Of course
toolbox.
there is.
Yeah.
You got to blow the dust on them when you get them off and when you get them out.
You know what? Sometimes no drama at all to have carbs set up, or like if you've got 671 like blower shit, and then have carbs on top and have fuel injectors in the bottom.
Yeah.
Like, man, that's the
I
good
don't think
way
I've
to
ever
do
seen
it.
a carby injector combo.
That's the right way to do it, because you're getting all of that junk through the top, however they meter that
And
shit.
then the injectors are kind
then
of
the injectors are there to-
making it nicer in the port.
Yeah.
And then you're doing like per cylinder tuning then.
Yeah, that's the secret, is doing the overall tune from the top and then the individual cylinders down the bottom.
You're doing the trim at the bottom effectively.
Yeah.
Huh.
And so I think that's the nicest way to do those style of cars. Or old school stuff that they want to have a carb sitting on top because it looks cool, but then have electronic ignition as well.
Yeah.
Like, that's a thing. Like, that makes complete sense.
First and reverse are quite close together.
So are the pedals. Jesus. I'm
Yeah,
gonna
I
have to take my shoes off.
I haven't got a manual dead pedal yet. So once I have that, I can actually change the position of the pedals.
Oh, hang on, let me get my little...
Get your boot in
We
there.
might have to swap shoes, man.
You did have like a size 15 shoe though.
Have you got a light? Dave did this car. Surely there's a button for light down there.
There's no, that's
Oh.
reverse.
Oh,
Yeah.
it is an L series. Are you lying?
It's a Great Wall gearbox. You know that, don't you?
No.
It's out of a Great Wall Ute. Great Wall copied the Toyota box, the
This
R
is
series.
the 86 thing.
No, totally different. This is an R series like an R154,
Right.
but in 6-speed. It's
So
out of
in
a
what car?
Great Wall diesel Ute. V200.
way.
Yeah. $800.
I bet they're not $800 now.
Oh, they're like $1,100 now.
Oh,
Fourth.
jeez.
Yeah, it's
Gearbox
close.
feels like it's out of a bloody Great Wall.
Funny that. It's out of an OK wall.
All right, so we've got a noise in the back. What do you reckon that noise is?
That nang, 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 nang. That'll be tail shaft resonance probably.
I reckon that's something
Touching the dyno.
the chassis of the dyno, because we're low boy. Well, first thing we'll do is we're going to calibrate the speedo, then we're going to get out and have a look at what's touching, and then figure out if we have control of this or if we're on our own. So it's going to bring it up to 60 k's an hour, load into it a bit, calibrate. Done. Speedo's done. On the mainline dyno, we can also do a speed test. So if you need that for this car,
Yeah, right.
we can print out the measured roller speed, which is a known quantity,
Yeah.
versus the speedo in this car to make sure that it's within X%, so that you know that the speedo's bang on. I know it's
wow.
going to be, but it's
That's
just
cool.
a handy thing to
But
have.
that's probably more for like analog speedos to see if there's a variation, like it walks away.
Spot on. I think a lot of the compliance stuff is based on all the old things where this has to be right now
Because it's electronic.
they're all known. While we're in this area, we'll also do the gear ratio stuff. First gear.
5th and 6th are going to be noisy
Oh yeah?
because the mount, because it's like really firm mount, gets a resonance in 5th and 6th.
You sure that's not just because it's out of a Great Wall?
I mean, it could be. Straight cut 5th and 6th.
Yeah, that's what it is. That's actually... And guess what else has just happened?
Well, the noise has gone away.
Yeah.
Self-clearancing.
We ground up away enough of it that we're on. All right, so now I'm going to hit C for cell fan to turn my fan up in the dyno to not kill us. Just put a little bit of load on it. And while we've been doing this, I've been watching the short-term and the long-term trims just to see what's going on. All right, I'm going to let you in on another little secret.
Yeah.
while we're mucking around, kind of getting a bit of a feel for injector dead times and how it all works, I've got the long-term trims turned off.
Yeah.
I'm gonna turn everything on to do it as fast as it can. I'm not even going to look at the base fuel table. All I'm going to do, I'm going to hold it here, look at my target, look at my actual, and go, okay, they're out by, it's pulling about 10% there. I'm going to help it do its job in the long-term tables, and I'm just going to keep filling it out in the long terms.
Oh.
Look at the transition there between light, that's really good there, and then wide open. It just wants so much fuel there.
Yeah. Is that actually detonating then?
Nah, that's the noise out of the carbs.
Yeah, okay. The carbs.
Oh, I say carbs, but
I know what you mean.
It wants
heaps of fuel.
Heaps of fuel, and there's so much of a transition there that we'll put another load side in.
Ah, that's cool. I'd like to see what the headers look like at the end of this.
We'll go back and forward and we'll put ignition timing in and out. All right, so what we'll do, apply all of this so we start to get like a little bit of a shape into kind of what it's supposed to look like, which I'm kind of guessing we're going to look like this. What we'll do, this is looking realistic. I'm going to go through and take out 6 everywhere, and then we're going to look at the cam control and get a feel for what the cam control's doing. Fourth gear takeoff. How's the torque? What I'm looking at here, the target, the actual, same here, and the error. So I'm just making sure the cam control's actually working.
Mad.
How's the honk? Still wants more fuel there, which is telling me that there's something else going on, and it might be, where's the map sensor getting its reading from?
It's got a vacuum log. So it's got 6 individual ports between the throttle blade and the cylinder head.
Right, okay.
That goes into a block, and that block comes into the cabin and goes to the brake booster.
I wonder if there's something a little bit weird going on there. Not the end of the world.
Yeah.
But this could also come back to trying to calculate like the injector size, injector data as well.
Yeah.
But what I'm basically doing is I'm trying to get my actual mixture to be the same as my target mixture.
Yeah. And then that shift is telling you what the variation is.
That's how far wrong I am. And I'm happy with under 5%, whatever. Stop it. Stop it. All right. Feeling pretty good. So,
not your first rodeo.
So all we'll do is go back and forward. This shape is probably in the ballpark.
So what's your thoughts on injector times? We're good with all that?
Yeah, everything feels about right.
Because I feel like we wouldn't be doing fuel correction and changing if you weren't happy with the injectors.
No. So the secret is to do it all at about 50 kilowatts. You can't do it at idle, because at idle there's this much dead time and there's this much injection time. So it's, say, roughly a millisecond of dead time and 0.1 seconds of injection time. So you can't make assumptions based on the injector size because it's all dead time.
It's not working.
Whereas if you hold it at about 40 or 50 kilowatts, we still have the same dead time, but then now we've got 3 or 4 milliseconds of injection time.
Yeah, you've got a reasonable margin of operation then.
So now we've got a better idea of what the flow rate is and what the dead time is. And then, while we're on that, so now let's bring the thing to idle for a second.
Every time I watch this, it just blows me away. There's so much in tuning, but there's so much just in your head, and it's just almost automatic. Just watching you fill all these tables out. And
it's been a long time, and there's a lot going on everywhere. But if we get the idea that I'm going to set it up so that we're roughly in the ballpark. See this? How we're kind of, we've got a little bit flaky. The mixture's trying its hardest, but we're hunting up and down. Tells me that the dead times are probably a tiny bit too low, which they're at a very low number. So I'm just going to go 0.5 milliseconds. Starts to smoothen out a little bit. Our short-term trims are going to be pulling fuel out while we're doing this. Remembering as well, multi-throttled and cammed, so we might also...
You could be chasing a problem that doesn't actually exist.
Because we might not be able to achieve a target idle of 14.7. It might not be happy. But I can feel in the car now that that's not happy. So I'm going to come back one. I'm going to ballpark it there. And then I'm going to go my target lambda table. My target's 14. My actual's close enough. And my error is 1 or 2%. Zeros.
Yeah.
So to see if I'm in the ballpark, I'm now going to target 12 at idle.
And see if it has the same error.
Yep. So now, target's 12, actual's 12. Engine doesn't like being there.
But it's coming back.
But within reason, there's a 1, so we were at 1%, now we're at 2% error. I'm going to go to 11.0. Little bit more. Okay, so this is telling me that our dead times aren't correct.
Okay.
Bit of a clean out of that. We're going to put all these values back here because that looks a bit nicer. And then the other thing we can do as well is free rev it back up. And we'll have a look at what the numbers are here. So this is telling me that the dead times are probably a tiny bit too high, would be my guess. It's got that pop out the pipe, that's the camshaft, so it doesn't want to be at that mixture.
Yeah. So that shifter's tightening up again there.
Still pretty much in the ballpark, so let's go back to our target lambda again. And go for 11, so I think was what we went for. I think we might have been too keen. We might need to do this at a higher RPM, because at the moment, even when we're trying for between 11s and 12s, you can definitely feel that she's a bit uncertain about it.
It sounds so much sharper already.
It's pretty cool, eh? I'm gonna put just here.
Like I thought it sounded sharp before, and then now it's like a totally different thing already.
It does have enough manifold pressure to tune it using manifold pressure, but if we wanted to, we could change the load axis to a throttle position.
Yeah.
But it's feeling nice. We're getting good tunability. It's kind of working. So
you're actually using the map as the primary load for this? Okay.
Yeah, and it's got enough.
I thought we'd have to do like hybrid or throttle or...
It's pretty happy.
Okay, well that's good to know.
If we need more axes, we could.
Yeah, right, so you can change the divisions across the scaling of it.
Yeah, so I could change that to throttle position instead of manifold pressure.
Yeah, okay.
I'm going to crank up the filtering a little bit everywhere. But look, while the axes are there and it's happy, I'm not gonna bother. So our fuel's in the ballpark, our ignition timing's in the ballpark, but now, cam angle. So let's look at how much torque it's making at that particular spot. .322. So, a few things we're going to try at this one spot. How much cam advance are we allowed? 45 is the biggest number.
Yeah, but we won't have that much because we got the lockout plate. Or is that telling you what it's got?
So if I ask for 50, it's getting 45 and it's maxed out.
Yeah, because I've locked it out. Because
so we can get up to 45.
So what's the factory go to?
I think it's 45. Well, it might be 49.
Okay, well, it must. Yeah.
So
It's
all I'm
locked out a fair bit.
So all I'm going to do, forget the mapping altogether. 10. We just went from 270.
And what was 322?
322.
So once more there.
Once more. So now I'll put 20 degrees. $313. $25. $25.
So it doesn't care for it now then.
25.
So you've found the limit of where more advanced doesn't mean it's not doing any more.
Not doing any more. So
what do you then pull 2 degrees back off, or just that's the max?
Cam timing, basically in 5 degree increments, is pretty reasonable.
Okay, righto.
So what we'll do is we'll do a couple of pulls. We'll get in the ballpark. I have cheated a little bit because I've done a few VE motors and I know that this shape is roughly right.
Yeah.
So what I was trying to do then was verify that what I've got is right and it feels good. So now we'll go through and we've done a whole bunch of steady state stuff, meaning all the light load bit.
Yeah.
So now we'll do a couple of power runs because we've made 70 kilowatts, 325 newton meters.
That's all it's going to make though, isn't it?
That's it, we're done. But there's a mechanical sympathy part, right, where in a perfect world, I would steady state every single load site, every RPM.
Yeah.
But at $2,000, I could see you were like, eh. And at $2,500, you're like, eh. At $3,000, you're thinking, oh, I hope it's put together right.
Should be right.
About
Toyota put the bottom end together.
$3,500, something like that. I steady state as high as the car wants to, and then use power runs to do the rest.
Yeah.
Power runs and data logging, because otherwise it's not.
You can beat on it all day.
It's not realistic. And the other, this thing's going to make whatever power, and an aspirated motor, following the rules, you can do it. What happens when it's a 300 kilowatt or a 500 kilowatt 2 litre? You can't.
You're just wringing its neck all day. You're
can't,
literally shortening its lifespan.
Like, I'm sure that factories do that. Steady state, that's not real. It's
yeah,
not
but
a
they
reality.
always do that because they kill one, they go and pull another one off the rack and go again.
Yeah, and they write down,
they go,
oh,
that
one did X amount of hours.
Yeah,
interesting. Okay,
too
move
hot.
on. All right, so you're ready? What do we do now?
Send it. What's the RPM limit at the moment?
7,000.
Righto.
All right. What should I set the screen to? How many kilowatts? It's up at 500 kilowatts at the moment.
I think that's probably a little ambitious. Go to 200 for the fun of it.
Yeah, what I'll do, I'm going to calibrate the tacho speed on the dyno. So I'm doing 1830 for gear set. So now the dyno knows what engine RPM we've got, so it can do a derived torque calculation.
Yeah, nice.
I'm going to hit my data logger. 100 and we're going to end at 118 kilowatts, so it's going to make 110. How about you?
125. I'm going ambitious.
I hope you're right, man. Whatever happens from here, it sounds amazing.
Oh yeah, it's never been about the number.
All right, you ready? Data logger's on. 1, 2, 3. Hit it. Stop it. Biggest L series I've ever seen.
Hey,
Hit the spacebar, hit the spacebar.
look out.
I apologise. I apologise.
K24
I'm sorry.
who?
I'm sorry. I apologise. The egg is on my face, and insult to injury. Can you see the RPM written there at 7,000?
7,000, and it wants more.
The rev limit is at 7 grand.
Yeah. And it hasn't really stopped yet.
Sorry. Well, this is awkward. I
That's
know.
cool, huh?
Bro,
So
it
there's
sounds-
some magic there then,
It
right?
sounds awesome. Let's change the subject. How good does it sound?
Are you genuinely surprised by that?
Yeah, that's sick.
Cool.
Because the truth, like, they just don't make power. They're aspirated, like it is what it is.
Yeah.
With the exception of this one. Makes power.
So there's obviously some goodness with the cams, the springs, the throttles. Like stuff is
you
working?
said compression.
Yeah, but not a lot. I just decked the head. Like it hasn't.
Okay, yeah, so-
it doesn't. It's stock. It's a stock 300,000 k old 2J bottom end. It literally came out of my mate's mum's car. It was a GS300 I dragged out of a paddock in Bega.
I love it. So after that, bit of work to muck around and we have a look at what happened during that run. So the whole time my eyes were glued on the dyno screen at the AFR, but we've got the engine protection turned on anyway. So I'm looking at it thinking, right, if it goes above 14, the dotted line at the top, I was
Yeah.
going to pull out of it.
Yeah.
But the engine protection was going to turn it off before I would pull out of it
Your
anyway.
response is slower than the ECU.
So smile and nod and just have a good time. And
Yeah.
as long as your protections are set up, we're good. These yellow line, these two here, that's my target and my actual. So I wanted 12.7, I had 12.9. I've set my, we're close enough, and I've set my targets very reasonably and responsibly, so we can actually lean it out to try and see any power, but in my experience,
it's not. You're chasing 2 kilowatts here, right?
it's not enough percentage gain for the lack of engine protection
Yeah, the
from
potential
adding the
damage
fuel in.
versus
Um,
risk versus reward, right?
And then this is the part I like saying, that this is the pat on the back bit where short-term trim, how much was the ECU doing to help me to achieve my target?
Minimal. 3%, 2 to 3%.
3. So, and remember up here, this was all a guess.
Yeah.
It's dropped off there because it's on the engine limiter and we don't
Yeah.
do any protection on the limiter.
Yeah.
And you can see that I held it on the limiter there for half a second at the end. And I do that just to sit it on the top and make sure there's no funny business.
That it's actually going to get there.
So all I'm going to do is go, okay, so from about 5.5 grand onwards, I'll go back to here, 5.5 grand onwards, 4%.
More fuel.
More fuel, because that's what the short term was doing. So I'll just smooth that in and make it look pretty. So there is a hint here that our injector flow rate is not correct, because this engine is not 120% efficient.
No.
It's somewhere between about 40 and about 95.
Yeah.
But that tells me that there's error in our injector flow rate,
Or the dead time.
our dead time, our engine size, or our manifold pressure. I don't know whether it's the injector
It's not the
flow
engine
rate.
size.
Can't be the engine size. It could be the manifold pressure, because we
Yeah.
might not be getting a true representation.
Could that be because the brake booster is involved in that circuit?
Yeah, and just because of the length of vacuum hose, because it's going through the whole coupling thing, there might be a delay there.
Yeah.
The reality,
Is there any truth to the having all the vacuum length lines the same length?
I don't think so. No.
The internet told me I had to,
Good.
and I didn't, and then
I think by the
It
time
still works.
you're getting to that,
We're at
it's the
F1
wrong
level.
it's the wrong system. You
Yeah,
shouldn't
yeah.
be doing that.
yeah,
So I am going to leave it, which is probably a little bit taboo, but you can have numbers up to 200 in here to accommodate for just error that you're not going to know about. So
yeah. The car's still going to run the same, right? It's just
It'll-
if someone looked at that map, they're
And
like,
they go, "Oh, that's
a
weird."
bit weird.
yeah, but when you don't have all of the data, we give you the tool set to tune the car, not to calibrate to a F1 spec like you're saying.
Yeah.
There's a lot of value in the 4-hour tune where you need to get the job in and get the job out, and you need the tool set to be able to do it.
Yeah.
So
The practicality side of it says, the theoretical says that number's wrong, but practically it works as a system, so
it works.
it's a workaround.
Yeah, spot on. Yeah, the alternative is right now, you go, okay, you've just had your 4 hours or 6 hours with the dyno tuner.
Start again.
Start again, or pull your injectors out and flow them, or put a set of known quality injectors in it when the only thing that we're battling is that the VE number is not what we're expecting it to see.
Which doesn't really make sense, right? Like as far as redoing all that stuff.
If we want proof in the pudding of that, we can do some funny business here. Control A, P, minus 20, enter. Sounds a bit nasty. Flow rate. Minus 20, enter. Oh, okay, looks pretty good now. So it's literally the same thing. So I've just pulled 20% out of the VE map, and now I've made the injectors 20% smaller, and it's idling with a short turn trim of 1%. Oh, it's the same again.
So all you do is move the goalposts.
We're calibrating to suit the environment that we have. And if you've built the whole car and you've chosen all the injectors and all that stuff, you'll know. But as a dyno tuner, hey, things turn up. You got injectors from 1980. You got coils from 2000 and, well, I'm going to say 2007 because they're going to be R35 coils.
Yeah.
We're back in the game. You're going to tune the next car, right? Like the next one, you'll know everything.
Yeah.
Gangster. Let's go back to here.
I do try and learn something every time we come here.
I do enjoy it.
I don't think I'm in the driver's seat anytime soon, though.
Target and actual cam angle, mint, they rolled over together. So in any of these things, we want to advance the cam arguably as far as we can down low, and then retard it as we come higher and higher.
When you say retard, you don't mean past zero, do you? It's more...
No, typically on a
as
VVP...
in reduce advance.
Yeah, so back to zero.
Yeah.
So typically we can't cross zero with variable cam timing. It's normally not a thing. Most exhaust cam, or most intake cams, they'll advance up to 30, 40, 50 degrees, and then they'll retard back to, in this particular case, zero at the top. Some manufacturers, very rarely, they go the other way. So if you unplug them, they're fully advanced. Whereas this, if you unplug it, it's fully retarded.
Yeah. Do you know a random good way to check piston to valve clearance on a JZ?
No.
At full advance? Roll it backwards. The cam goes full advance if you roll the engine backwards.
You've got no oil pressure.
Yeah. Like if you've got it on a stand, you roll it backwards and it'll tell you if you're good or bad.
Oh, I like it. That's a good way to find out. Or good time to find out.
We found out.
And it did?
It did, yeah. I ended up having to shim the VCT to reduce total advance.
Interesting.
But evidently not. We haven't actually taken that much out of it.
And it's nice that you say that because, like, someone will correct me. I'm not aware of anything where you can advance the camshafts in the software enough to hit something and make a bad problem, except for when it's custom. But in a factory application, that's not a real thing. It's not
possible. No. Like Toyota wouldn't have allowed enough advance.
No, not a thing.
At the OE level, because they've got to think of fail-safes. If what happens if that VCT hangs open,
that's exactly
and you've got
the problem.
Full advance at idle, and pistons and valves aren't friends.
We're in trouble quick.
Yeah, really quick.
Hey, this number here.
Pump it up. 75, 80. Oh, okay, cool. I'm good.
You said it's a stock bottom end. It's a 2J. It's probably worth $500.
I'm just worried about the rod bolts.
Well, they're probably only worth $20.
Yeah,
if they break, we'll just replace them.
The value is the head, though. Should be right.
What could possibly go wrong?
Famous
one
last
rod
words.
bolt. What's it worth? $5. You replace. If it breaks, we'll just replace it.
Yeah. Okay.
Spacebar. Enter. Enter. Cross your rod bolts.
Give me a spacebar again.
Not yet. Give me a sec. So if you're pressing the spacebar, this is basically your responsibility.
It's my responsibility now. Okay, no responsibility.
All right, so F6, start data logging. I'm going to bring it up. So we're in the ballpark now. I'm about to go wide open throttle. 3, 2, 1, hit it. I was just experimenting with the cam timing down low, so don't be too worried about that.
Yeah.
Revs wise, what do you reckon?
So I made the same power. What's the torque?
Let's have a look.
See where the torque dies off.
So this is kind of where we're looking from.
There's no real point revving it, is there?
Like
Sounds cool, but
the derived torque, it's making like 170 newton meters. I think you're probably on the money. 7.5 seems
just
realistic.
split the difference.
Somewhere around there. All right, so we bring that back and we know what's up.
Sounds phenomenal at 8.
Stop the data logging. We just got to 8,016 RPM.
Value for money.
Sounds good. I wanted to go there too.
It's pretty good for a 3. It's testament to how well Toyota engineered stuff back in the day, eh?
Yeah.
Literally a paddock fine engine that I didn't touch the bottom end.
Yeah, it's quite extraordinary, eh?
Because I was like, I've kind of been second guessing the whole, oh, we should have done the bottom end and put pistons in it and bumped the comp up, and there's no real reason to do that, right? Like it would have made another 10 kilowatts maybe with higher comp.
Yeah, and just
or more torque, or
wants a bit more again up the top there, so we hadn't been there yet.
Yeah, that's kind of fair enough though.
All right, so now we're going to put 2 degrees of ignition timing in it. We'll see what happens. So nope.
Didn't like that at the top, eh?
No, didn't like
Loved
that.
it in the middle, but that's probably just more cam timing, right?
Yeah. So we'll go again.
Something like that.
Happy.
Doing love, aren't you?
I love it. I really do. Yeah, don't worry about that. You're right.
I love bringing you cars that you love.
One of the things we'll do now, actually, we're going to lose a whole bunch of bottom end, but I want to see if we need to turn the cams off earlier.
So you can do a run with no cam on at all.
So basically what I'm going to do,
And then cross them over.
P for percentage, minus 33. So I pulled about 10 degrees of cam timing out of it everywhere. Silky smooth. All right, hit it. Happy? Look what we
So it wants less cam.
Look what we got down up there, but up the top. So if we go space bar. So basically from 57 and below,
It wants less.
good.
And then above it wants what it had before.
Yep. So from about there, okay, that gives us the best of everything. What was the number there? Space bar? Ah, I didn't see it. I didn't look. Yeah, look at the difference that we're up.
It chases it harder in the blue line, but
Yeah. It is a significant difference.
Yeah.
Like there.
that's like, what, 20 kilowatts or something?
There's 22% in torque.
Oh, that's torque.
22% in the worst one, and then
Yeah.
5% difference in torque. Like, it's in an aspirated setup where you really
That's a massive difference.
you need everything. Like, it's
Yeah.
good. Yeah.
So I guess this is the benefit of going VVTi versus non.
Yeah.
you've got that. It's more bottom and mid-range than top end, obviously.
Yeah. If you had vernier king views, like we could be out there adjusting.
We do have an exhaust one,
2, 2,
but
2, 2, 2.
yeah.
The reality is, it's making.
It just works, eh?
It just works. Yeah, it's good. Really good. We are petroling at the moment.
Yeah.
What are we thinking? Oh, yeah, if I'll have a quick look. This is our long-term trims. After we've been doing that, this is how much we're correcting by. So I'm happy with that.
That's sick.
That
eh?
one anomaly there of 6%. My gut feeling is that
That's map sensory stuff.
it's probably when I'm holding it on load there, it's probably reverberating and there's some weird shit going on.
Like map sensor reversion or something.
So what I'm going to do there is turn my trims right down there. So I don't want it to be learning much there.
Yeah, okay.
Because I think there's a bit of funny data there.
Then you might end up actually creating an issue by adding the trims rather than ignoring them.
Spot on, yeah. And in deep decel, we don't have much love there. So, all right, that's what's going on. We'll do that one too. All right, we'll apply there. What do you want to do now? I think we let it cool down. We'll put the fan on, let it cool down. Give it
Fuel swap?
one more pull.
Yeah, then fuel swap.
Fuel swap. So, knowing that we're going to fuel swap.
Oh, can you set that up too, please?
Yep. What do you want it to do?
Fuel pump override.
Should make you do this. Fuel pump. Primary pump override. Assign to.
Keep that.
It's
That one.
That one. And what's the behavior of the button?
Latching.
Ah. Sorry, fuel pump. Remember last state.
Oh man.
Ready for our give it hell moment. Very nice. Cooling system's been magical at like 90 the whole time as well.
I'm stoked with that because the one compromise that I did have with the cooling system, we didn't have a lot of real estate for big fans.
Yeah, gotcha.
Like the diameter of the fan's big, but the motor is really small.
Yeah, okay.
But they're still 1300 CFM fans and two of them with a proper shroud. So it's like, we should be right.
Go. Spacebar.
New high score.
That's where we're at. You see the mixtures on that? It just like comes back to idle, beautiful. It's really nice.
Dope.
I love the noise. The little blip, you really have to go wide open so it like stalls up down the bottom.
Snaps it, yeah.
That sounds sick. All right, what do we do now?
Fuel swap?
Let me quickly look at that last data log and then just good practice. I like to save that last log as the last one that was the, like the last petrol log. Wideband, perfect. Short-term target, perfect. What are we actually doing? What? Arguably nothing, 1 or 0, perfect. Oil pressure, perfect. Fuel pressure.
You'd hope that doesn't move.
Perfect.
Why does it dip?
That's me, that's the expected.
Ah, sorry. Oh, so the red line's actual.
Yeah, so the reason for that is probably going to be because it says that it's vacuum referenced.
It's not.
So that's
Yeah, I
my
probably should have told you that.
No, that's all right, that's my mistake. We'll change that to constant. That doesn't have any effect on the tune-up. Beautiful, looking good. Fuel and oil looks fantastic. Coolant, temperature. Why can't I see that? Oh, thank you. perfect.
It's rock solid, eh? It just sits there.
Battery voltage is called device battery voltage. Perfect, can't argue. Mate,
Health check tick.
things are looking good.
ECG looks great.
Yeah, kind of does look like that, doesn't it?
I don't love that if that's an ECG. Oh, not bad.
Injector duty cycle, we're at 55%, give or take. All right.
Yeah, cool.
What do we do now?
Fuel swap.
We will now go, we're already flex fueled, but what I'm going to do is go F3, add a new table axes, 0, 20, 4, 0. We can probably do a whole bunch of axes, to be honest, to do a bunch of data logging. 0, 10, 20, 30, 40, 50, 60, 70.
Anything above 70 is just whatever anyway, right?
All going to be the same. Yep. Well, I shouldn't have said that. They're not all going to be the same, but 70 to 80.
Yeah, the
Yeah.
octane isn't usable anyway, right? I think we've had that conversation before.
What we could do, if you really wanted to be, you actually caught me out then. So you'd be rarely at 40, so we'll let that interpolate. But we'll put one at 80. So now, that's where we're at. We're 20, 30, 40. So now we've got all these table axes. The reason I'm doing this now is because I want to put it into my long-term tables because I don't want your flex fuel to mess up my
Petrol tune.
yeah,
So it'll separate. It's like an and/or type deal.
80. There we go. Yeah, so now if we're up here, there's
Not
all
looking
these,
at the petrol.
not looking at the petrol map, there's all these different tables now.
So it's making its own table
Spot on.
in the long-term trim based on ethanol composition.
Exactly
or fuel
right.
composition.
And then we can do exactly the same thing for the ethanol content in the petrol in the ignition map. So now, at the moment, we're sort of there. So we're interpolating mostly the petrol map,
Yeah.
little bit of the ethanol map. But when I flick it over, so to make that clear, on ethanol, if I just said I wanted the whole thing to have 30 degrees, that's the ethanol map. And that's where that little ball is showing me where we're at.
Yeah, that's cool, eh?
So I've messed that whole map up. So I'm going to go Control Z just to undo. We'll make them both the same for the time being. Cross
And
our
then do
fingers.
you just then go, oh, that's ignition. So for, say, your injection map,
Yep.
do you then just add a scalar and go plus 38% as a base?
I do not,
Okay.
because this is still the VE map. This part, in theory, isn't going to change. You've already told me that you want flex fuel here. So the software is already doing all of this work in the background for you. So in theory...
So it bases... Okay, because this is back to our injection time versus VE
Yeah.
conversation, right?
Yeah.
So my head has just gone injection time then, when I go that plus
Yep.
38%.
So this table is already filled out for you in the background, and that is already doing the work. As long as, so this is how much
Yeah, cool.
of the correction it's adding in the background based on the composition of the fuel. So if it's E30, it adds 33.6% of this value, or of the difference between petrol and ethanol. Now, if we've got the wrong injector flow rate, wrong engine size, wrong map reading, it won't work perfectly, and we'll need to do small corrections. And in that case, fuel comp correction. So we'll come down here. So this is our table to make up for any errors in the data.
Yeah, okay, so you can data log and then look at what that's... Will the ECU populate that table?
No, it won't.
Or so you pull data from the data log and then fill it out based on that data?
That's right. And we might be like, oh, everywhere it's just 10% too much.
So you just go minus or plus 10%.
Yeah. So I'll do the table axes for that one. So the other thing that we'll do, I might actually do the ignition time. I'll do the ignition timing a different way to show you. So we'll knock that off. We've also got comp corrections down here for ignition timing. So how this can work is, okay, if we're at E10, add 12% of these values to the ignition map. And we'll knock off that 10,000, we'll knock them off. So it might want more ignition timing, right? If it was on it. So let's just say it was on straight E85. Let's put 5 degrees there. Let's put 3 there. I'm just making this up. I don't know what it's going to be. That might be how much more timing we want to add. So if it was on E70 onwards, add 100%
Of that table.
of this table to our base table.
That's cool.
But if it's on E10,
It's doing 12% of that
do
correction.
nothing. I don't want you to do anything. We'll make
Yeah,
it extra
okay.
safe. If you get to E25, please add 32% of this to the base.
That's cool.
Happy?
Yeah, that's mad.
All right, and then from here, do we both get out and go and do the fuel, or what do you want to do?
Yeah, it won't take long anyway. I have a system. You'll be impressed with it, hopefully. The pump out's complete.
She's off.
Thanks, mate.
Yeah, so...
You're playing with it now.
Sorry.
You like that?
Really nice.
Watch me pour 5 litres of fuel down a really clean, polished quarter panel. Can't wait. Technique.
So as soon as we put the fuel in it, now we haven't turned the ignition on yet, so we're still online. I'm going to turn the ignition on, and we've got our fuel composition here. Are you ready? Pumps
Should
on.
be running, yeah.
And look what...
Yeah.
Where'd you get the fuel from?
United.
So we're at... Let it mix, let it do its thing for a while, remembering that there is petrol in the bottom of the tank. So
we might not get a full pump out.
So we'll let it mix for a while. So you've got your override on the CAN keypad, so the pump's just running without the engine running.
Yeah, so that'll be pumping all the fuel through, and then once the return starts to cycle it, it'll level out.
Yeah. So the reason I've got 2 channels here as well, this one's the raw sensor value. So that's 66%. That's what's actually coming out of the sensor. This one is what the ECU is using for all the fuel corrections. So if we're above 2000 RPM, that will be locked at that value. Yeah. Okay, so we're mixing. It's kind of happening.
67's the number.
All right, so let me turn off the pump. We've got our short terms, we've got our long terms, we've got all of the trims are already in there. What do? You reckon we just start it and see what happens?
Yeah, see what it does. See if it idles, if it's happy.
All right, so remembering that all we've done is just the math part of it. Oh, the other part, fuel comp, see the arrows up here now? So if I press space bar, this is where we are, 67%. So what I'm going to do, just so we've got no interpolation and no funny stuff, I'm going to delete that one, and I'm going to put the axes at 67. So now I know I'm right on that site for when I'm mucking around.
Yeah.
All right, the ignition off all the way and then on. Fuel pump primes, hit the key. Might try that again, because it should start good. On, hit the key. I'm just waiting for the sensor to warm up and see where we're at.
Is the ECU kind of guessing before you've got a sensor input?
It's just sitting there, doesn't do any correction.
Okay.
So not terrible for just us start with the mass behind it. It revs, it does everything normal. We'll let it come back to idle and see what's going on. And at the moment, what are we at? We're at 2, 3, 4%. And before, when it was sitting at 10s or 11s, it could be as simple as there's still air in the rail from pumping all the fuel out of it. The idle controls, something's going on there where, okay, so our throttle position is now at arguably 0, but our RPM's sitting up. Interesting. I wonder if that's from heat soak on the manifold.
And the throttle's grown.
Yeah. So now the TPS it's shutting as much as it wants to shut, but our idle is up here.
And that's just purely because the heat soak.
It's got air, just can't do anything about it.
Yeah.
Throttle pumps are magical, everything's fantastic. It's just, we're done. Don't you think that's extraordinary?
It's cool, eh?
Here we go. We'll now go through and we'll check some of the load sites to make sure that everything's looking good. All right. So what I want to do, see on the right, I want to go 40 kilometers an hour. So if you go plus and minus, the top left, the one where it says 58, can you see that? Yep, bring us to 40. I've got some load into it. You keep going and you're dragging us down. Beautiful. All right, so all I want to look at.
School zone tune.
So what I typically do is, in the beginning of the adventure, you might notice that I did all the RPM sites, but then after it's tuned and I'm happy, I then do all of the speed sites because they're different. And I want to make sure that both are perfect, and it's just another way.
So you don't have that weird surge at a certain vehicle speed in a gear.
It's just check, just another way to verify and cross-check everything we've done. So I'm looking here, and our targets and actuals. All right, so we do need a bit of love here. So our long terms are going to be doing that, but all I'm going to do is manipulate until all of our trims are in the ballpark. All right, bring us up to 50 k's an hour. The speedo is also bang on too. Short-term trim is now pulling 10% out here, so it's just a bit of funny business there. All right, keep coming.
Sorry?
60. Beautiful. 70. 80. Oh. Keep coming up a bit. We'll do this up to 100.
You want to go 90 now?
Yeah. Beautiful. 100. I did put a rough ignition map into it, but what I'm going to do is knock it out back to 0. So this is only a fuel change, nothing else. Fans are on. Do you want to go F2? That purple one that's on the screen right now was the, and it says 133, but it was the actual graph.
Yeah.
Just press spacebar and we're apples with apples. All right, so we've got the same ignition advance, but the fuel's been corrected so that we got the right mixtures, and we're targeting the same air-fuel ratio on petrol as we are on ethanol, which we could lean it out a bit if we wanted on ethanol, but for the purpose of this, we're not going to.
Yeah.
All right, start logging, spacebar, wide open, hit it. So the first thing I want to point out, which I think is extraordinary, same mixtures. Literally the identical mixtures over the top of each other.
That's wild, eh?
How cool. First pull, no magic, nothing going on. Horsepower wise, up until 5.5, 6 grand, arguably the same. And then up the top, it may have given up
200 horsepower.
200 horsepower.
Whoa.
So we'll change that to E85.
And that's with no more timing.
0 timing changes, fuel only.
That's cool. But it made like, what, 1 kilowatt different?
Yeah, yep. So if we just pull those last 2 runs up. Yep. So on petrol versus the red one is on ethanol. The difference in torque, there might be like 15 newton meters or something in it.
Makes more up the top, but it's marginal.
Yeah. It's all of that. Yes, it's an improvement. It's all marginal.
Yeah.
Let's humour me.
Put 2 degrees in it.
We'll put a bit of an ignition shape into it, which it can now cop. We'll cross our fingers. Man, now that you're working that keyboard, we're ripping through this.
Oh, easy.
Can you stay all day? All right, spacebar that. We might have got another horsepower.
Woof. That's like another 4 horsepower.
So let's have a look at what torque, what gain we just made. Like,
We're splitting hairs here.
we're absolutely splitting hairs. Look, there is insurance there.
Yeah.
Like, it's better to be on ethanol, but I also understand that it's hard to get.
It's inconvenient.
Inconvenient. Look, in the aspirated world, you've picked up, call it, you picked up about 18 newton meters.
What's that? Is that a thing in the real world? Is that even gonna? Is there gonna be a
Honda
note?
guy would be, this is gangster. Like,
Oh, okay.
so,
if I had a K24, it's like I just won the lotto.
well, if you went from 135 to 150 kilowatts, I don't care how you did it with a K series.
Yeah.
Good, like, solid.
Yeah.
So we're different frames of thought, right? Because like in one of your other cars, it might be 15 kilowatts between pulls, just if it's a Tuesday or a Thursday.
Yeah.
But 15 kilowatts aspirated is hard to get.
Yeah.
So, 15 newton meters, 20 newton meters.
Yeah.
So, look, is it worth it for the added complexity of multi-fuels, flex fuel tuning, budgeting for it in the fuel system? Look, no, I don't think so.
I suppose that the budgeting portion of your statement, if you're building a car from scratch,
Yeah.
it's probably negligible if you're already buying injectors and a pump
Fair.
and a filter and all the other bits. The price, and these days, most pumps and injectors are actually ethanol rated.
Fair.
And anything under a 750cc injector about costs the same.
Yeah, and that's kind of
So
the
if you're going
default
ASPO,
anyway.
yeah, like these are 440s, I think. So if you're going ASPO, that's kind of plenty of injector anyway. Like no one's trying to slam 1250cc fuel injectors in this thing because it's pointless.
Yeah, all seems very reasonable. Yeah. So,
It's probably actually harder to find smaller stuff.
that'd be true, yeah, I guess.
At this engine size, you may actually pay more for a smaller injector, say a 380 or a 330 or 280. They're not an easy injector to come by, and even more so to fit that individual throttle system. There may be some obscure OEM injector that's $150 a piece.
Remembering, I suppose, one of the other things, complications, and that as well as where do you get the fuel? So that's probably a hard thing now that like if you have to tramp all over your state to get the fuel,
Yeah.
probably not worth it. If it's a local thing, maybe.
I think that's the beauty of flex too,
Yes.
versus
Yeah.
true E85 tune.
Can I show you this? This is the part that I love this bit. So because the maths is there, that's our wideband, that's our RPM, that's our target. Because we put the effort in on the petrol and the petrol tune-up's perfect,
It's basically calculations
Look
at
at
that
it.
point, not retuning.
look at it, it's pulling 1%, and our target on the long-term and short-term factor is 1%. I want it to be 1% rich and the short-term to be pulling out 1%. That's the goal here, because if the O2 sensor fails, O2 control turns off and it will run 1% richer than the target. Done.
Yeah, wow.
And that is textbook. That is so brilliant. I'm really happy with that. The mixtures are flat. I think that the last thing we've got to do, we've been doing a whole bunch of wide open throttle pulls. I'm now going to do a pull at, say, 80%, 60%, 40%, 20%, just to make sure that the mixtures all stay in the ballpark and things are nice. And then we're good to go.
Mad.
All right, we'll go 80%.
That's the power you thought we were going to make.
Yeah, yep, about there. Must be the throttles.
Job done. 38 kilowatts.
That's the rear brake.
I was going to say, is it the dyno brake or the car brakes?
Bit of both. I think
Nice.
more the rear brake in the car, to be honest.
Yeah. The next train to arrive on platform 1. All
might,
stations to Wynyard.
Let those discs turn around a little bit.
Yeah. No, you're supposed to just come into the
sorry,
pits,
handbrake. Sorry, handbrake
rip
on.
the handbrake on and call it done and walk away.
So the actual throttle shape, like, yeah, you know, it does have throttle in it.
Character.
Like, yeah.
It's not just slam the air in it.
Character. Good word.
Mm.
Yep. While
So,
we're here,
I guess a question, if you were to actually design and make a throttle body kit for the 2J,
yeah.
how big would you make the throttles?
What size are these?
These are 45s, and they're as small as I could get.
I reckon I would
40s?
do 40 mil.
Yeah.
Yep.
Because they're like, oh, 45 or 50, and I'm like, no, 50.
No. Yeah. Well, remembering that, have you ever done the cross-sectional diameter of a 68 millimeter throttle body to 72 millimeter?
No, it's massive.
When you do the maths, you're like, nah, that's not right. That can't be right. And then when you
how big of a
actually
difference?
do it, you go, whoa, it is huge. Yep. And the number of square millimeters on a throttle body, throttle plate is like, whoa.
Well, like, the Crest is probably a good example of that. It makes 1,300-ish horsepower.
Yeah.
And it has the factory FG throttle body on it.
Yeah. Yeah.
And you see all these guys putting 100 mil throttle, like Aspo car, different story. Like if you're going like an all-motor Honda, the bigger the hole, the better. But when you're jamming 4 atmospheres into it,
yeah. Isn't that interesting? And I agree with you that my only comment on that would be about like an LS engine, a cammed aspirated thing, bigger the better.
yeah,
But as soon as you go anything else, it doesn't work.
put the stock throttle body on it.
Yeah. Here we go. And there's our long-term fuel trims. Probably a few little erroneous bits there.
Fill it outliers, basically, possibly based on funny map sensor things. you
Throttle
reckon?
pumping, just mucking around. But other than that, that's where we're at.
Are you going to leave the long-term trims on?
Yep.
Yeah, mad.
And you'll see there, we've never been to 80%, but it's
Yeah.
biasing that much of the 70% map and that much of the 80% map.
Interesting.
So we're gonna apply that. Shut all that. And that's where we're at.
And that's how you bake a turkey.
That you can bake a turkey. All right, I'm about to...
Ask one on-camera question.
Yes.
At the end of your runs, when you're hitting limiter and then the car's coming back down in revs, you're blipping it twice every time. Is there a reason for that?
To keep the oil pressure.
Okay.
So I think probably there's a couple of different... that if we just clutch in and go straight back to idle, I just feel guilty because it's just got no oil pressure to cool everything.
Right.
So I like the blipping. I like the noise of this car, so that's probably something. But yeah, overall, some people like hold it will just free rev it to like $5,000 as the dyno's coming down, just to help everything to. Probably also a nice thing that if it blips twice, you know that it's still got rod bolts in it as well. Also convenient.
If it blips once and then goes, that's a bad time.
Well, what a spectacular outcome. A few myths arguably busted. My 2J does make more power than a K24.
You proved me wrong. All right. It made very good power, which sometimes we don't really see that when you put cams in something and when you've got no compression like in a piston. What are you working with? You know,
Yeah.
there's not a lot of room to move, especially with something that doesn't make a huge amount of power in stock form.
Yeah.
So that's where my guessing was come from, but killed it. Like, it's awesome. On petrol, it drives super nice. The throttles work better than any other individual throttle style setup I've seen. Beautiful, really, really nice.
Oh, thanks, mate. Appreciate that.
They really emulate that inline 6-cylinder L series sound.
Yeah. Without the smell and the fire, hopefully.
They're beautiful. What did you think about the ethanol part of it? Was that interesting?
Pretty cool. You know, I have always wanted to do this kind of pump 98 versus pump E85, almost like a Mythbusters type of vibe. Like, what is pros, cons? Is there any point to even doing it? Like, and the thing that I never even actually factored in, my brain was very power based, but you mentioned kind of the torque and picking up, what do we pick up, 17 or 18 newton meters or something?
Call it 18 newton meters, which up the top, down low, it seemed like it wasn't limited by the 98 petrol. Up high, it seemed like it wanted a tiny little bit of ignition timing, and the cooling effect of the ethanol's probably helping up there to make a small gain, but in like looking at what we've got, it's pretty impressive.
Percentage based, it's a good number. Like, it's not setting the world on fire as far as peak numbers or a massive number, but when you look at that as a percentage from petrol to ethanol, it's actually quite a good gain. And even the power figure from our best 98 run to our best E85 run, I think was about 5 kilowatts, 7 horsepower, give or take.
So not crazy, but
as a
percentage-wise, and what else would you do? How else would you make that power?
Yeah, like, and in this form, like without physically, mechanically, or hardware changing things, what else do you do? It's not like a turbo. You put another 3 pound in it and make 50 horsepower.
Yeah,
you just don't have that same yield with the NA thing. Everything is like that 2%. Like, we could port the head. We could put 11.5 to 1 comp pistons in it. We could take the VVTi shim out of it and potentially, although we did kind of prove that it didn't actually like that much cam timing. So playing around with the VVT, even having that restricted phaser, it doesn't seem to have actually negatively impacted the combo at all. So I'm actually really happy about that, because that was the one thing I was kind of a little bit hesitant or concerned with, but I was also like, well, mechanically the valves can hit the pistons, so even though we could electronically limit that in the ECU, in the tuning, there was always that potential to go, if worst case some mechanical issue forced the VVT into full advance, say the solenoid jammed open and just went full oil pressure, full advance, the pistons and the valves would have been friends, and mechanically that's a bad time.
It's just not a thing that you want to leave out in the open, because this car will go on for another 50 years. Like, who knows what's going to happen.
Yeah. But I'm really stoked with the outcome.
Tuning-wise, the difference between petrol and ethanol and the way in the software to do it, I'm always really excited about that.
That blows me away. Like, even Gian mentioned, I don't know if we caught it on camera or not, but his mentality or his view was the 98 tune is one tune, and then you fully tune it again on E85 and then do this kind of crossover comparison to get your composition levels. But these days it's realistically more mathematical or calculation based.
A lot of blending. It's a really, really nice. Probably the one thing I want to point out in that is spend as much time as you can on the petrol or the base fuel tune, because any errors in the base fuel tune, now that you can see how that works,
mathematically amplified,
copied straight across, spot on. So the more you put into the low-powered petrol tune, the better it's going to be.
The drivability stuff and your hot starting and all that sort of deal.
Spot on.
It's wicked. Like, it's cool to watch. Same thing I said before. Every time we come here, I try and learn something or pick something up, and it's cool to just observe you just going nuts on the keyboard, because there's so many tables that I still don't understand, and watching you just populate all of those, a lot of it from memory and through learning previously. Like, you've been doing this for like forever.
A long time.
20 years or something.
Yeah.
But no, it's really cool to see. But another one that works, so
Awesome.
pretty stoked with that. Really appreciate your time as usual, mate.
Pleasure. I'm super keen to hear it come past at the racetrack on song.
I wish.
And hear it rip all of those gears, just because the noise out of that one is definitely different.
Yeah, I'm stoked.
Yeah.
Thanks so much, mate.
Always a pleasure.
Appreciate it.
Thanks for coming.
See you on the next one. Thanks for watching, guys. We'll see you next time.